Hello and welcome. I need to tell you about something that happened 3 days ago that has astronomers working around the clock to understand what they are seeing. On the morning of November 18th at 0900 hours Universal Time, the interstellar object known as 3I Atlas crossed a threshold that no predictive model had accounted for. Not one calculation, not one simulation, not one trajectory analysis from any research institution on Earth anticipated what this object would do at that precise moment. And what makes this truly concerning is that we have been tracking this object continuously for 7 months. We thought we understood its behavior. We were wrong. Let me start from the beginning so you understand why this matters. 3I Atlas entered our solar system in April from the direction of the constellation Lyra. It came from interstellar space moving at a velocity that proved it was not gravitationally bound to our Sun. That made it the third confirmed interstellar visitor we have ever detected. The first was Oumuamua in 2017. The second was Comet Borisov in 2019. Each of these objects taught us something new. Each one challenged our assumptions, but neither of them did what 3I Atlas just did. When scientists first detected this object, they followed standard protocols. They calculated its trajectory, they measured its brightness, they analyzed its spectrum to determine composition. They built computer models to predict how it would behave as it approached the Sun, swung around, and headed back out to interstellar space. These models are sophisticated. They account for gravitational forces from every planet. They account for radiation pressure from the Sun. They account for potential outgassing if the object contains volatile materials that could turn to gas when heated. The models have been refined over decades. They work. They are reliable until 3 days ago. 3I Atlas followed those predictions perfectly. Its path matched what the model said it should do. Its brightness changed in ways that made sense based on distance and angle. Everything was proceeding as expected. Scientists had high confidence in their projections. They knew where the object would be at any given time. They knew how bright it would appear. They knew what to expect. And then at 0900 hours on November 18th, something changed. The object reached a point in space that the models had calculated it would reach at that exact time. The trajectory was perfect. But when it reached that point, it entered a state that no model had predicted. Its brightness spiked, not gradually, instantaneously. In the span of less than 30 seconds, the object became 4 times brighter than it had been, and it has remained at that brightness level ever since. Let me be clear about what I mean by instantaneous. When I say the brightness increased in less than 30 seconds, I mean that monitoring instruments showed baseline brightness at 0859:30 and then at 900:00 the brightness had quadrupled. There was no ramp-up. There was no gradual transition. It was like someone flipped a switch. Natural phenomena do not behave this way. When comets brighten, they do so over hours or days as ices vaporize and create clouds of gas and dust. When asteroids tumble and present different surfaces to Earth, brightness changes smoothly as the rotation progresses. Even explosive events like impacts or sudden fragmentation show characteristic signatures: a rise time, a peak, a decline. What happened to 3I Atlas shows none of that. It went from state A to state B with no transition period, and it has stayed in state B. The European Space Agency was the first to confirm the event. Their satellites had been monitoring the object as part of routine tracking. When the brightness spike occurred, automated systems flagged it as an anomaly. Within minutes, human analysts were reviewing the data. They checked for instrument malfunction, they checked for calibration errors, they checked every possible source of false signal. Everything checked out. The instruments were functioning correctly. The spike was real. NASA's Deep Space Network confirmed it independently 17 minutes later. Different telescopes, different instruments, different location on Earth. Same result. The object had brightened by a factor of 4. The timestamp matched 0900 hours Universal Time. Ground-based observatories across 3 continents reported the same thing over the next 2 hours as night fell in different time zones, and telescopes could point at that region of sky. Gemini Observatory in Hawaii, the Keck telescopes, observatories in Chile, all saw the same elevated brightness. All confirmed the timing. This was not an error. This was not a glitch. The object had changed. Now you might think a brightness increase could have several explanations, and you would be right to think that scientists immediately began testing hypotheses. The first and most obvious explanation was outgassing. Perhaps the object had been heated by the sun and volatile materials were suddenly vaporizing, creating a cloud of reflective gas and dust around the object. This is exactly what happens with comets. As they approach the sun, ices turn to gas, jets erupt from the surface, and brightness increases dramatically. But there were problems with that explanation. First, the timing. 3I Atlas was not at its closest approach to the Sun when this happened. It had already passed perihelion back in September. It was moving away from the Sun. It was getting cooler, not hotter. Outgassing events triggered by solar heating happen on approach, not on departure. And they happen at predictable distances based on the composition of the object. Scientists know these thresholds. They had been monitoring for outgassing throughout the object's approach. They saw nothing. Second, the instantaneous nature of the brightness change. Outgassing does not turn on like a light switch. When a comet begins to outgas, there is a period where cracks form in the surface, pressure builds up, and then material begins to escape. It is a process. It takes time. Even violent outbursts where pressure suddenly releases all at once show a characteristic signature, a rapid rise, yes, but also a peak and then a decline as the material disperses. 3I Atlas showed a rise with no decline. It stayed bright. Third, spectroscopic analysis. When objects outgaze, they create specific signatures in the light spectrum, emission lines from excited atoms and molecules. Observers immediately trained spectroscopes on 3I Atlas to look for these signatures. They found nothing, no emission lines, no signs of gas, no signs of dust. The spectrum looked almost identical to before the brightness change, just brighter. That makes no sense. If the object is surrounded by a new cloud of material, the spectrum should change. But it did not, so if not outgassing, then what? The next hypothesis was fragmentation. Perhaps the object had broken apart, perhaps internal stresses or a weak structure had caused it to split into pieces, increasing the total surface area and thus the total reflected light. This has been observed before with comets and asteroids. They break up, they create debris fields. Total brightness increases because there is more surface area reflecting sunlight. But fragmentation also has signatures. When objects break apart, the fragments move away from each other. Over hours and days, you see the single point of light in the telescope split into multiple points as the pieces separate. Observers looked for this. They took high-resolution images with the best telescopes available. They saw a single point source, no fragments, no debris field. The object appeared to be intact. There was also the problem of timing again. Why would fragmentation happen at that particular moment? Objects fragment because of stress, thermal stress from rapid heating and cooling, rotational stress if the object is spinning too fast, tidal stress if it passes too close to a planet. But 3I Atlas was not under any unusual stress on November 18th. It was in open space, far from planets, moving along a predictable path. There was no obvious trigger for sudden fragmentation. A third hypothesis was that the object had collided with something. Space is not empty. There is dust. There are small rocks. Perhaps 3I Atlas had hit something at high speed, creating a brief flash and ejecting material that increased reflectivity. But collisions are random. The odds of a collision happening at a specific predictable point in space are infinitesimally small. And collisions create expanding debris clouds that fade over time. The brightness of 3I Atlas has not faded, it remains elevated. This is where things became truly strange. Scientists went back to their models. They re-examined every parameter. They checked their calculations. They looked for any factor they might have missed that could explain why the object would brighten at that particular location in space. And they found something interesting. Not an explanation, but a correlation. The point where 3I Atlas brightened corresponds to a very specific geometric relationship with Earth. At 0900 hours on November 18th, the object was positioned such that the line connecting it to Earth and the line connecting it to the Sun formed a precise angle, 47.3 degrees. That is a specific number. And what made it noteworthy is that at that exact geometric configuration, the object changed state. Now you might say that is a coincidence. Space is full of angles. At any given moment, objects are at various angles relative to each other. Why would this particular angle matter? That is exactly what scientists asked, and they could not answer it. There is no known physical mechanism that would cause an object to suddenly brighten when it reaches a specific angle relative to Earth and the Sun. Natural objects do not care about geometric relationships with planets. They respond to forces, gravity, heat, radiation pressure. None of those forces suddenly change at a specific angle, but the correlation was undeniable. The object reached that geometric configuration at 0900 hours. At 0900 hours, it brightened. The precision of the timing made coincidence hard to accept. There is more. In the days following the brightness change, additional anomalies emerged. The object's rotation, which had been measured at 6.7 hours based on periodic brightness variations, appeared to have stopped, or more accurately, the periodic variations stopped. Before November 18th, observers saw the object brighten and dim every 6.7 hours as it tumbled through space. After November 18th, the brightness remained constant. No variations, as if the object had stopped rotating or as if the rotation no longer affected what we see. Objects do not spontaneously stop rotating in space. There is no friction, no air resistance. Once something is spinning, it keeps spinning unless acted upon by an external force. What force could stop a 200-meter object from rotating? And why would that force act at the exact moment the object reached a specific geometric configuration? The scientific community is deeply unsettled. I have been in contact with colleagues at multiple institutions. The conversations are guarded. There is reluctance to speculate publicly, but privately there is confusion. No one has a good explanation. Theories are being proposed and discarded as quickly as they arise. Each explanation requires assumptions that seem more unlikely than the observations themselves. NASA elevated the object to priority status on November 19th. That means more resources, more telescope time, higher urgency. The director of the Jet Propulsion Laboratory stated in an internal memo, which was later made public, that 3I Atlas represents an unprecedented observational challenge and that understanding its behavior is now a top priority for the agency. Those are strong words. NASA does not use language like that casually. The SETI Institute requested and received data access on November 20th. The search for extraterrestrial intelligence does not typically concern itself with asteroids or comets. They listen for radio signals, they search for technosignatures. The fact that they are now analyzing data from a physical object tells you something about how this is being perceived. They are looking for patterns, looking for information content in the brightness changes, looking for anything that might indicate intentional behavior. I spoke with a researcher who has been involved in these analyses. I cannot name this person because they are not authorized to speak publicly, but they told me something that I have not seen reported anywhere. They said that the brightness increase on November 18th was not the only anomaly. There were smaller, shorter duration brightness fluctuations in the hours leading up to the main event, flickers lasting only seconds each, occurring at irregular intervals. These were initially dismissed as noise, instrumental artifacts. But after the main event, researchers went back and reanalyzed that earlier data. The flickers were real. They occurred in the 30 minutes before 0900 hours, and then they stopped, and then the main brightness increase happened. What does that mean? I do not know. Neither does anyone else. but it adds another layer. It suggests that whatever caused the brightness increase did not happen suddenly out of nowhere. There was a precursor, a lead-up, a period of instability or activity before the main event. That pattern is consistent with a system transitioning between states, not consistent with random processes. There is also the question of what happens next. The object is now moving away from us. Every day it gets farther from Earth and harder to observe. We have perhaps 2 more months of good observation time before it becomes too dim for all but the largest telescopes. After that, it will fade into the background of space. We will lose it, and whatever it is doing, whatever state it has entered, we may never understand it. That creates urgency. If there are additional measurements to be made, additional data to collect that might shed light on this mystery, it needs to happen now. Observatories around the world have cleared schedules. Telescope time, normally reserved for other projects, has been reassigned. Everyone wants data on this object. Everyone wants to be the one who figures out what is happening. But here is what troubles me most. The models failed. Not slightly, not with minor errors that could be corrected. They failed completely. They did not predict this state. They did not anticipate this behavior. And these are not bad models. These are sophisticated simulations built on well-tested physics. They work for every other object we track. Asteroids, comets, spacecraft, planets, they work. But they did not work for 3I Atlas. When models fail, it means one of two things. Either the object is experiencing conditions or forces we did not account for, or the object is not behaving according to natural laws in the way we understand them. I hesitate to say that second part. It sounds dramatic. It sounds like the kind of thing people say when they want attention. But I have been watching the data for 3 days. I have seen the timeline. I have seen the precision of the timing. I have seen the correlations, and I cannot construct a scenario using known physics that explains everything we are seeing. Let me give you specific numbers so you understand the statistical problem. The probability that a randomly tumbling object would stop showing rotational brightness variations at any given moment is related to the number of possible states it can be in. For a typical asteroid, that probability is perhaps 1 in several thousand at any given observation. The probability that it would do so at the exact moment it reaches a specific geometric angle relative to Earth and Sun is that baseline probability multiplied by the probability of that geometric configuration, which for a specific angle to within measurable precision is roughly 1 in several million. The probability that it would also show precursor fluctuations in the 30 minutes before is harder to calculate, but adds at least another factor of 1 in several thousand. When you multiply these probabilities together, you get numbers like 1 in several billion. Those are lottery-winning odds, except this is not a lottery, this is physics. Physics does not produce lottery-winning coincidences. There is a concept called Bayesian reasoning. It says you should update your beliefs based on new evidence. When you see something extremely unlikely under your current model, you should consider whether your model is wrong. The more unlikely the observation, the more seriously you should consider alternative models. What we are seeing with 3I Atlas is extremely unlikely under standard models of asteroid and comet behavior. That means we should seriously consider alternative models. But what are the alternatives? One alternative is that there is new physics, some force or interaction we have not discovered that becomes relevant under specific conditions that 3I Atlas happened to meet. That is possible. Physics is not complete. We discover new things. But new physics that becomes relevant at a specific geometric angle, that would be very strange physics, and it would have implications far beyond this one object. Another alternative is that the object is not entirely natural, that it contains or consists of something that was made, something that responds to conditions in ways that natural rocks and ice do not. I know how that sounds. I know the immediate reaction, but I am not speculating wildly. I am following the logic of the data. When natural explanations require increasingly contrived scenarios, and when the observations show patterns consistent with designed or intentional behavior, it becomes intellectually dishonest to ignore that possibility just because it makes us uncomfortable. I am not saying Three-Eye Atlas is artificial. I am saying that hypothesis deserves consideration alongside the others, and it appears that serious institutions are considering it. SETI would not be involved otherwise. NASA would not have elevated this to top priority if they thought it was a routine comet outburst. Something about this object has triggered protocols normally reserved for truly anomalous events. What would it mean if an interstellar object turned out to be artificial? It would mean we are not alone. It would mean technology exists or existed somewhere else. It would mean that at least once in the history of the universe, another civilization built something and sent it out into space, and it traveled for however many millions of years until it happened to pass through our solar system at a time when we had the capability to detect it. The implications are staggering. Everything changes. But we are not there yet. We do not have proof. We have anomalies. We have data that does not fit our models. We have correlations we cannot explain. That is not the same as proof. And scientists are right to be cautious. Extraordinary claims require extraordinary evidence. We do not have extraordinary evidence yet. We have puzzling evidence. What we need is more data, more observations, more measurements, and we need them before this object disappears from view. The clock is running. Every day that passes is a day of lost opportunity. The brightness remains elevated, the rotation remains stopped or hidden. The object continues on its path away from us, and we still do not know why it changed state on November 18th. I encourage you to follow this story. I encourage you to look at the data if you have the technical background to understand it. Most of it is being made publicly available through astronomical databases. You can see the brightness measurements yourself. You can see the timeline. You can verify that what I am telling you is accurate. This is not speculation. This is documented observation. If you found this information valuable, please share it. The more people paying attention to this, the better. Science benefits from scrutiny. It benefits from multiple perspectives. Someone out there might have an insight that has been missed. Someone might see a pattern that others have not noticed. The solution to this mystery could come from anywhere, but it will only come if people are paying attention. We are watching something unprecedented unfold in real time. An object from another star system has entered our solar system and is behaving in ways we cannot fully explain. That has never happened before in the history of astronomy. This is not like Oumuamua, which was strange but ultimately could be explained with creative applications of known physics. This is different. This is an object that changed state at a predictable location in ways our models did not predict. That is a failure of understanding. And failures of understanding are how we learn. They are how science advances. They are opportunities. I will continue monitoring this situation. I will continue speaking with colleagues who are analyzing the data, and I will share updates as new information becomes available. This story is not over. It may just be beginning. Thank you for your time and attention. This matters. Pay attention.